point, you are supposed to brush up on your division skills. Okay. Let's go over some vocabulary terms first. The result of a division problem is a what? We divide by the divisor. What is being divided? Ooh, look at you guys. Did the video have those words on it? Some of them. And then if we have a remainder, then we tack it on to the end over our divisor. Right? And in that video, there were a few examples. I know at least one of them had a remainder, right? Okay. Now, what I'm going to do in preparation for our first theorem is I'm going to call our dividend f of x, our divisor d of x, our quotient q of x, and our remainder r of x. Now this is how you would write your answer if I ask you to simply divide. Okay? Now, do you think there's a way we could rewrite this expression right here to where there's no more fractions? What could we multiply by to get rid of the fractions?
D of x.
Okay, if we take both sides, and don't write this down necessarily right now, but if we multiply by that divisor, it cancels over here, it cancels right here, and then the divisor gets multiplied to the quotient. Right? You see that? We distribute it to all three of those, cancel out the denominator, and then it gets tacked onto the quotient. Okay? That is what's called the division algorithm. Just write the division algorithm. Don't write all of these words. What I circled in red is the division algorithm. It's essentially what we wrote, multiplied by that divisor, so now things are just rearranged a little bit. It's a way for us to write a function in terms of its quotient, divisor, and remainder. The first few problems in your homework are going to ask you, and I'll even read the words specifically. Use the remainder theorem to rewrite the function in this form. Okay? So first of all, we're going to do a division problem. Go ahead and write down the division problem we're going to do. We're going to work it out together, so just copying it down would be fine. But as you copy it down, I want you to be thinking silently about which type of division we're going to need to use. Or do we have an option? Okay, we have synthetic and long division. I want you to think about which one would be best in this scenario. Tell your neighbor which one you think is best in line. Trennan, which is best?
Long.
Why?
Why not?
Why not? Can we use synthetic division?
No. I have no idea.
You're not sure? Okay. Did you have a discussion with your neighbor about why long division was better? Partly. You decided on the long division,
Yeah.
but not quite sure of why. Okay. Logan, you're just very excited.
Well, you can't use synthesized division because it's not line. Because that is not line. The
Our
by
divisor. Okay, our divisor needs to be linear in order to use synthetic division. Okay, and since we don't have a linear divisor, we can't do that.
It's gonna be a rough one.
She said.
Change your attitude. Change your
You guys
attitude.
are all smart.
Wait, so are you?
I'm not as smart as that.
Yes, you are. So, if you have any missing terms, it's important to put a 0 placeholder. Okay? Our dividend does not have any missing terms, but our divisor does. Not as important, but we might as well get the practice. I'm going to go ahead and put in a 0x here so we can be organized with our work. Okay? If there's a missing term, put a 0 placeholder in there. Okay. All right, so if you accidentally didn't watch the video last night, x squared times what is 2x cubed?
2x.
Okay, put 2x in the x column. Divisor times that 2x would be 2x cubed plus 0x squared plus 2x. Okay. Remember, at this point we subtract. Just so you don't lose track of what's happening, I would just put the subtraction all the way through. That way you don't have to try to remember you're subtracting and then accidentally forget. Okay, so these should always go away. We have negative x squared minus 0x squared and 3x minus 2x. Okay, so we perform the subtraction, take down the next term. When you bring down that constant term, you know you're on your last step. Hooray. X squared times what is negative 8x squared? Negative 8. Put that in the column with all the other constants. So our divisor times negative 8. And we are subtracting. So I'm going to just change the signs here. So our x squareds go away. X minus 0x. And then negative 9 plus 8. When we performed the division, our quotient is 2x minus 8, and we get a remainder of x minus 1. Okay. So let's talk about what we just did there. We took 2x cubed minus 8x squared plus 3x minus 9. We divided it by x squared plus 1. Our result was 2x minus 8 with a remainder of x minus 1. If I asked you to perform the division, then this over here is the answer that I would expect. Okay. Questions on what I wrote in black up there? Okay. So let's talk about that division algorithm. Okay, if we have something like this is what we talked about on the very first slide. Okay. Remember we talked about how we can rewrite it to where we no longer have our divisor in the denominator. So if we multiply everything, so we multiply both sides by that divisor, we would get our function equals the quotient times the divisor plus the remainder. If we take both sides and we multiply by the divisor, it cancels out those divisors in the denominator, but then it also gets multiplied to that quotient. All it is rewriting.
Well, we need to simplify it.
Leave it like this. Because I can see that our function is being written in terms of the quotient, divisor, and remainder. Okay? Essentially, we can see all three of those things at once. Okay? Do you have a question? Okay. All right. We're going to talk about a couple theorems, and they're very much related. Okay? You will start to get flashbacks to Algebra 2. Okay? Let me know when you start to have some flashbacks. I mean, I know that this division was familiar, but just let me know. Okay? So first of all, and I'm going to go ahead and put a screen shade up here. We have the remainder theorem. If we divide a polynomial by x minus k, then the remainder is the function value at k. That might seem a little strange right now. Write it down. We'll work through an example and I can specifically point out what I mean. When we perform synthetic division with x minus k, our remainder is the function value for k. Write this example down, we'll go through it, and I'll talk about specifically what this means.
This one has
Is there a glare?
Yeah.
Okay.
What does it say after procedure? What?
R equals f of k. I'll shut the blinds, Renaya. Is that better? Okay. Trennan, can we use synthetic division?
No. Yes. One of them.
One of them we can use. What was our rule of synthetic division?
Square have a line.
Okay, is x plus 1 a line? Y equals x plus 1. Is that a line? Yes. Yes, okay. So we have a linear divisor, which means we can use synthetic division. And that one goes quicker, right? We can all agree synthetic division goes quicker?
Yes.
Okay. If we're dividing by x plus 1, what goes out here? Negative 1 goes out there. X minus k, we throw k over here. Okay? And then 2x cubed minus 8x squared minus 3x minus 9. If there's a missing term, you got to put a 0 there. We don't have that issue. Okay, remember how to do this?
Yep.
Bring down the 2. 2 times negative 1 is negative 2. Add to get negative 10. Multiply negative 10 to negative 1. Add to get 7. Multiply 7 times negative 1 to get negative 7. add to get negative 16. Okay? I put a little bar right there so I can identify that the remainder is negative 16. Yes?
Was that on purpose because you were over the 9 and the 9 doesn't have any x to it?
Yeah, so the remainder is always going to be this number when you're in that
If there's a
constant
C.
column. Yeah. Okay. Who had a question? Thought somebody had a question. No? Okay. So our remainder is negative 16. What this remainder theorem is saying, that if we call this f of x, then what we found is that f of negative 1 equals negative 16. If we take 2 times negative 1 cubed minus 8 times negative 1 squared minus 3 times negative 1 minus 9, it will be negative 16. But it was much easier, especially without a calculator, to do that synthetic division. I mean, maybe not since it was negative 1. But maybe with something like 5, where I don't really want to cube 5 and square 5 and then subtract those, and you know what I mean? Plugging into synthetic division gives us the same thing. Okay. Does that make sense? Questions?
I don't get the f of -1.
Okay, so we performed this division, right? So whatever is out here, that's the number that if we plug that into our function, our y value will be whatever the remainder is.
Okay.
Does that
makes sense.
is that better? Okay. So you at your pod work together on this one for me.
Oh, dear, that's a lot harder.
Sorry.
Probably not.
Oh.
That was hard.
Did you do it? Did you?
Zero.
5
I had to wrong. I didn't argue it.
It works out.
This.
There's no
All right. What happens, guys?
There's no remainder.
There's no remainder. There's no remainder. What does that mean? We're done.
Yeah.
Okay, so it means f of 5 is 0. What else does it mean? Doesn't mean anything. Do you think it's special because we don't have a remainder? What do you say? Okay. Specifically, a y value of 0 means what? That it is a 0. So we found a 0. We have found an x-intercept. Yeah? Okay. Okay. What would it mean about x minus 5?
It's on that.
Yes.
That's right.
Yes, we've established that. Okay. Ah, x minus 5 is a factor. if we have something that divides evenly into a polynomial, then it is a factor. All right? If x minus k divides evenly, we have a factor.
Having flashbacks.
Are you having flashbacks?
Yes.
Yeah. Well, what's coming back about algebra 2 and all this stuff?
This is a way to find zeros.
Okay. So do you remember like plugging in all those random numbers and trying to get a 0 at the end? We'll eventually get there, but that is what this is leading to. Okay. Monday's the day of the rational zeros test. Negative Nancy.
That's why it's phenomenal.
Thanks. Good. I'm so glad. Okay, so here might be a way that I present you with a question. Verify that this is a factor. So please write it down in your notes like this. Given this cubic function, verify x plus 3 is a factor. And we'll do it together. Just give me a moment.
That two's not negative.
If x plus 3 is a factor, what do we hope to have as a remainder? Excellent. Alex, what number goes right here? Negative 3. If we're dividing by x plus 3, negative 3 goes out there. So help me out. We drop down the 3, multiply to get negative 9, add to negative 7, multiply to 21. Is it going to work? Is it going to work? Woohoo! It's a factor. And you should be able to tell me, since the remainder is 0, x plus 3 divides evenly, therefore it is a factor. Okay? What?
Do we already know that? You have to verify.
This is us verifying. And then tell me how you know. Since we got a remainder of 0, we know it's a factor. Okay, I might ask you to verbalize that. Now, our function, we now can say is x plus 3 times 3x squared minus 7x plus 2. Do you agree? So if I asked you for all of the factors, okay, so this is kind of separate. If I did ask you for all of the factors, could you do that? Yeah. There would be our 3 factors for our cubic function. Jackson, 3x times x is 3x squared. We need to multiply to 2, so I have 1 and 2. And I place them so that here we would get negative 6x, here we would get negative 1x, together making negative 7. Yes.
Well, there could be a question that's like, verify 3x minus 1 is a factor? Would we ever have
Could be. And if 3x minus 1 then you would have to use 1/3. More than likely right now we'll stick to x minus k, but when we get to Monday and we talk about the rational zeros test, then one of the zeros that we try could be like a 1/3 or a 3/2 or a fraction. Okay? So let's just kind of summarize here how we can use the remainder theorem. And you have all of this written down. Don't feel like you need to rewrite it. But first of all, when we do synthetic division, our remainder gives us our y value. More specifically, if that remainder is 0, we have found a 0, aka x-intercept, and we have found a factor, x minus k. Okay? We have 6 minutes left, and I think it's enough time to do this example. Are you ready? Okay. Okay. That's a 40. Yep. That is a 58. That kind of got squished.
Oh boy.
Yes, thank you.
You don't think so? Well, we can at least talk about how to do it. I actually think 5 minutes, because that's what we have now. Okay, I've given you a 4th degree polynomial. And I've given you 2 factors. Well, what do we know about x minus 5 if it is a factor? The remainder should be 0, right? So if we use synthetic division, 1, -4, -15, 58, -40. If we use synthetic division with x minus 5, we better get a 0 for our remainder, right? Okay. Let's do that. And one step ahead of myself, sorry. 1, 5, 1, 5, -10, -50, 8, 40. Hey, hey, hey. I get excited when there's a 0 as a remainder. Okay? Now, work smarter, not harder. We eventually want all of the factors. We have divided out x minus 5. We also know x plus 4 should divide evenly. So should we go back up to the original? No. We can use synthetic division again with -4. Did you write it down wrong? That is unfortunate. I'm very sorry about that. So now what we can do is we can do this synthetic division again. Oh, I like this screen. So 1, -4, -3, 12, 2, -8. Ooh. Okay. So what we know is that our function is x minus 5 times x plus 4 times this right here, x squared minus 3x plus 2. And can we factor that, Jackson?
Yeah.
How do we factor that? I have faith in you.
X plus, wait, -1. X minus 2.
And and we have all of the factors, which means we could plot those on our x-axis, and we can look at the beginning and ending behavior and draw the graph if we really want to. We don't have to today, but do you see what we did? Hey, hold on, because we still have like 2 minutes. Do you see how when we had the two factors, we took one out and used the result to take the next one out? Okay, if you've already done some work, use that result to go from there. Okay, so your homework, you're going to have some division algorithm. You're going to have some remainder theorem. And you're going to have a couple problems like we just did up here. Okay? Questions? Good job, fifth hour.